Okay, welcome back, students. So, in the DA lecture, we were studying the first approach of the algorithm design, which was the greedy technique for algorithm designing. And we have visited one of the examples which comes under this greedy approach of algorithm design, and that was the knapsack problem. Now, in the today's talk, we will be studying one more example which also comes under the greedy approach, and the technique is or the algorithm is known as job sequencing. Job sequencing with deadline, which means that a particular person is being asked to perform certain kinds of jobs. A person is asked to perform certain kinds of jobs or certain kinds of tasks from I is equal to 1 to n, and every task is attached a deadline. Means task number 1 should be completed in 3 hours, task number 2 should be completed in 4 hours. So the person whose this task is, who gives his tasks to another person for performing or for completing these tasks, he is attaching two things with his task. The first thing is the profit attached with every task, and the second thing is the first thing is the profit which he attaches to every task, and the second thing is the deadline that it should be completed in this much of the time. So we can take an example of like a case of typewriting, which normally sits outside the court complexes when we go in the court for a particular task. So this typewriting person is being asked by few customers that they had to do their tasks from 1 to 5. Somebody has to do one type of typewriting task, some other has to do another, and they are telling this typewriting guy that they will provide, they will offer a profit for performing each of their tasks of typewriting, but they are also attaching the deadline with each of their tasks. Now, in this case, we are having 5 tasks. That's 5 typewriting tasks for from 5 persons, and from 1 to 5, every task is attached with a profit and a deadline that it should be completed in the first hour only. It should be completed in 2 hours, or the person is saying that I will wait for 3 hours. Okay, you can complete my task for 3 hours. Now, this person, that is the typewriter who has to perform the sequence of all those operations or jobs. He has to use greedy approach. He has to use greedy algorithm to solve such problem so that he will arrange these tasks in a sequence that he will earn the maximum profit. And whenever we talk about the maximization, it becomes an optimization problem. And for an optimization problem, either something has to be maximized or something has to be minimized. So in this case, the typewriter to whom these 5 tasks are given, he will come up with a greedy approach by which he will be able to arrange these tasks in an order that he earns the maximum profit. And how he does that, we will simply go to the whiteboard and we will use the methodology of this work. So I would The total number of jobs this typewriter is being given from 5 customers, and every customer attaches a profit and a deadline that if you perform my task, I will pay this much of money to you, but you have to complete it within this deadline. So in the present case, the total profits attached with every job is 20, 15, 10, 5. Profits are always arranged in decreasing order from top to the bottom. Even if it is not arranged, you can arrange it by yourself while solving such problem. Deadline is 2 to 1, 3, and for the last one, the deadline was 3. Okay, this is the input which has been provided to this typewriter. So the total time these people will be waiting for their tasks to be executed. That means this J3 person to whom this job belongs, he tells the typewriter that I will be waiting for only 1 hour. That is, in the first 1 hour, you have to complete my job. Okay, and I will provide 10 rupees to you for performing my job, J3. These two persons, J1 and J2, they tell the typewriter that we can wait for 2 hours. If it takes 2 hours for you to complete our task, we can wait for 2 hours. And this J2 person tells us that if you perform my job, I will wait for 2 hours and I will provide 50 rupees to you. This J1 person tells us that I will also wait for 2 hours, okay, but I will provide 20 rupees for performing my job. Similarly, these two people say that I will wait for 3 hours, and this says I will pay 5, this says I will pay only 1 rupees. So the total time slot will be 3 hours. That is the maximum one. 0 to 1, 1 to 2, and 2 to 3. So the typewriter will perform the maximum operation for 3 hours because that is what the person is waiting for. 3 hours. He is telling that I will wait for 3 hours. Now I will start from this side. I will see which job is having the maximum profit because this is a greedy approach. The purpose is to increase some parameter which is the maximization problem, and the typewriter is having the goal that he should be having the maximum profit. So for maximum profit, it is the job J1. That is the person whose job is J1. He is saying that I will wait for 2 hours and I will provide 20 rupees to you. So he will wait for 2 hours, means the typewriter will give it this slot that, okay, brother, you come after 2 hours, 0 to 1, 1 to 2, means 2 hours, your job will be done. Okay, so I will write down profit below here. Its profit will be 20, J1. Now the typewriter or the greedy algorithm will do, it will move to the next step and will find which is having the next highest profit in the list, who is giving the maximum money to this typewriter. That is job J2. He is ready to provide 15 rupees and is also ready to wait for 2 hours. Means if I give him the slot from 2 to 3, that means I am telling him that you have to come after 3 hours. I would have done your task. But this person is saying that I will provide 50 rupees, but if you do my task only in 2 hours. Yes. So 2 hours means that I can put his task here, J2. That okay, you can come after 2 hours, your job will be done. But this slot is already assigned to J1. Okay. So I can't keep J2 here because this is already assigned to J1. Because it is having the maximum profit, I also can't lose it. So I will go one step backwards towards this. And I will see if there is any slot vacant on the left side from 0 to 1. Yes, the slot is vacant. So I will tell J2 that, okay, you provide me 15 rupees And I will give one more bonus point to you that you don't have to wait for 2 hours. You just come only after 1 hour. I will have done your work because this slot is vacant to me. He is ready to wait for 2 hours. But I am telling you, okay, you don't have to wait for 2 hours because I had nothing to do at the present moment. You can come just only after 1 hour, your job would have been done. So for J2, he will earn 15 rupees. Okay. Now we will go, these two are done. We will go now to the third step. The third profit is for J3, 10 rupees. But the problem is that the J3 is telling I will wait only for 1 hour. After 1 hour, my work should be done. So this greedy algorithm or this typewriter will look towards the slots. He will say, no, brother, my only slot is left. That is the slot number 3. If you wait for 3 hours, I am ready to do your work. But since your deadline is only 1 hour, I can't provide you. So this is done. This is done. This I can't be able to survive service. So you please go and find some other typewriter. Now this algorithm will go to the next step. That is task number 4 in the list, hang the maximum profit. Since it is hang 5 as the profit and it is ready to wait for 3 hours. Yes. So 1 will be given to it, 2 will be given to it. So it is ready to wait for 3 hours means I can tell it that, okay, I am scheduling your task here. You just go and have a picnic. After that, you come, your task will be done after 3 hours. And the profit this typewriter will earn will be 5 for this task. And now the algorithm will go to the last one, that is this one. But since it also, it's one means that this person won't be given the allocated the time slot because all the time slots are already allocated to the different jobs. At the so we can do one. We can also do one thing. So initially the here we arranged the J2 from in the time slot 0 to 1. But if we look closely to this table, we see that initially the J1 which was having profit of 20, and this person is ready to wait for 2 hours. So if we write J1 here, if we give the first slot to the J1 instead of J2, we are telling it that okay, you give me 20 rupees and you don't have to wait for 2 hours. I can arrange your sequence only in the first hour because this slot is open for me. So I can write J1 also here, and next it is the J2 who is having the maximum profit. Since it is ready to wait for 2 hours, and my 1 to 2 slot, that is the second slot, will be vacant because J1 will be on the first place. So I can keep J2 here also. So the point is that these two can be swapped with each other. J4 will be at the same place. So when we write the profit for this type of the job sequencing example, we say either the sequence J2 to J1 to J4 here, this sequence, or the solution could be by which the typewriter will earn the maximum profit. It could be also J1 to J2 to J4. Okay, that's one and the same thing. And when we write the solution of the job sequencing with deadline, we consider the job here. In the next column, we assign its slots, the solutions, and the total profit. Suppose in this present example, we have taken initially the job J1 and this solution, and we assign the slot 1 to 2 to it, 1 to 2 for J1. And this is the solution for J1 because it could be occupied or it could be given a slot in this domain. And the total profit we earn by giving it the slot from 1 to 2 is 20 rupees. Similarly, the next in the line is J2, and J2 will be given the slot from 0 to 1, 0 to 1, and already 1 to 2 is the previous one which will go here, and this will become the solution for two tasks, J1 comma J2, and the total profit will be 20 plus now the profit of J2, that will be 15. Now the J3 will come, since J3 is having deadline of 1 and we don't have any slot vacant for 1, so we ignore this person. Okay, we can't do your work. So the slots will be again the same, no change. The solution will be again the same, no change. And the profit will be again same because we are not performing any new task. So it will be 20 plus 15, that's 35. Now the J4 will come in the line, and J4 is been allocated the time slot from 2 to 3. That is for, we are telling it to wait for 3 hours, and it is also ready to wait for 3 hours because of its deadline. So the 0 and 1 will be initially what has been given to previous jobs 1 to 2, and this J4 will be given the slot from 2 to 3. And 35 plus its profit will be 5. That will get added. And then the J5 will come, since it is also requesting to have time slot of 3 hours and we don't have any vacancy. So the solution will remain unchanged, J1, J2, J4, and the total profit which this typewriter will earn by performing a sequence of the operations using the deadline concept will be 40. And there is one more example of the same pattern. The only thing is that the jobs numbers have been increased. Initially it was 5, now it is 7. And the corresponding deadline is given here. So I have given this example. I thought that I will give you this as an assignment for you people to think over it, how to solve. So let me keep it untouched and we will shift to the next. This is the solution, but you had to solve it yourself. The only thing is the number of jobs have increased by 2, the deadlines are given, and you have to see that which is the maximum profit this typewriter will give, allocate firstly, then who comes in the line. Accordingly, the same logic will be followed here also. Now coming to the algorithmic part of this job sequencing with deadline. This is the algorithm of the operations which we performed. So what it does is that initially it starts with a for loop from 1 to n. N means the total number of jobs. And here in our example, that is the first one, this one, in which we took the total number of jobs equal to 5. N is equal to 5. This was it. So that means the code will start from I is equal to 1 to 5. Yes, this algorithm code will start from I is equal to 1 to 5. Then do. It's telling set k. Let me not write that, just calculate the value of k. It's saying that calculate k. K will be equal to min, and inside there is max comma deadline. Deadline of I means deadline of the first job, since I is equal to 1 at the present time. So this means by taking this example into consideration, this example on the top, since we are at job 1, okay, we are at job 1. So k value will be equal to how much? It will be equal to, initially, it will be equal to d of max. This, go inside the brackets, d of max. D of max means the maximum deadline of the jobs. Okay, the maximum deadline of the jobs. Here, every job will be stored in an array and the maximum will be calculated, and that's 3. Okay, so it will be equal to, inside it will be equal to 3 maximum, and then there is job of I. Then there is job of deadline of I, which means deadline of job 1, because I is equal to 1. So that means deadline of job 1, that is equal to 2. So this will be equal to 2, 3 comma 2. And then we are calculating the minimum of what is inside those brackets. Here it is min. Okay. So when it is equal to min, so that means my k will be equal to 2. Let me keep it highlighted a little bit. I is equal to 1, k is equal to 2. Then the while loop starts. And what is say? If k is greater than or equal to 1. If k is greater than or equal to 1, k is 2, so means while is equal to true. While became true. The next step is if time slot of k is empty, which means if condition is ts means time slot of k is equal to 2 is empty. So I know that the maximum slots in this job will be from 0 to 1, 1 to 2, 2 to 3. Is time slot of 2 empty? Yes, that is empty. So it will be also true because it is not allocated to anyone. We will go down. Time slot of k is equal to job of I. So if it is empty, it is true. Then time slot of 2, give it to job I. Job I means job of 1. Okay. So this means that this time slot of 2, which is from 1 to 2, give it to job 1, and job 1 is our J1. And when we performed it till this point, if all those things are true, 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 we then break this loop and we go outside this loop. Then in the next iteration now, because our one task is performed, suppose this is iteration number 1, we break the loop and we go to iteration number 2. In 2, I will be equal to simply 2. Okay. Now, k will be again equal to how much? K will be again equal to, okay, because the J2's deadline is also 2, maximum is 3, so minimum will be taken. That's 2. Now, in this case, while will be again true, okay, because 2 is greater than or equal to 1. if time slot of k is empty, okay, if condition will become false, because if t of s of 2 is that empty, no, that's not empty because that has been given to j1, so this will become false. When it became false, so this means this condition is whole stopped, we will directly reach to set, and we will decrease k by 1. K is equal to k minus 1. So the new value inside the k will be equal to 1. When it is equal to 1, then we again go to here. If k is greater than or equal to 1, yes, it is equal to, while loop will be again true. If time slot of k, if time slot of k, while will be then again called, so it will, we will write it while will be true. If ts of k will be now equal to 1, is that empty? Yes. So in place of time slot of 1, assign the value of job of I, and I is equal to 2. So here the job 2 will be assigned in this slot. That is the time slot J1. J2 will be assigned here. Okay. Similarly, this algorithm will go on, and every job will be assigned into their respective job slots or time slots. So this was to make understand how its algorithm is working, job sequence with deadline. And I will be sharing this presentation with you today in the group so that you will come up with the solution of this thing. You will have an idea. Okay, now we will shift to the another topic, that is also the greedy algorithm, which comes under the design strategy of greedy approach. The topic is minimum spanning trees. Okay, so these are topics are coming under the graph. So the graph analysis will be done, and any operation on the graphs all come under the topic of this minimum spanning trees. Whatever we will study from here onwards, we have to deal with graphs simply. Suppose a graph is given here, 1, 2, 3, 4. Okay, a graph is given here, and it is a connected graph, both connected as well as a weighted graph, 5, 3, 6, 4. 5, 3, 6, 4. And in between the diagonal, one diagonal is connected, that is this one, and it's equal to 2. So you know that these nodes are known as vertices. Okay, and these edges or these connections in between different vertices, they are known as edges. Yes, these are the simple concepts of the graphs. And these numbers which are present on these edges, these are known as the cost. Every edge is connected in between the two vertices by some value, integer value, which is known as the cost. Cost could be anything. It could be the profit, it could be the distance, it could be anything. And cost could be negative also. Okay, it's not necessary that cost should be always a positive. This means if we go from Gandhinagar to Delhi, it will take 5 kilometers, for example, the distance is. But it could be also in the negative. That's like the stock market, how it drops its price. The profit, you can go in loss also. That could be represented in -5. Okay, so this cost could be both in positive as well as negative, and there could be also this cycle inside the graph. Cycle means this closed path from 4 to 3, 3 to 2, and 2 to 4. This diagram which is becoming here, this is known as cycle. So we are talking about the examples where all those things are valid. We are having set of vertices, set of edges, edge represented by a particular cost function. And if we go from 1 to 2, that's from this vertex with a cost of 5, and from 2 to 3 with a cost of 3, and from 3 to 4 with a cost of 6. Okay, this becomes spanning tree of this graph. If we write it graph 1, so this becomes spanning tree first of this G1, graph 1. Spanning tree means that every vertex in the original graph should be present in this subgraph also. There are 4 vertices here, there are 4 vertices. But the number of edges, there should be no closed path. There should be no closed path here in the spanning tree. It's not closed like it was here. And the third point is that the number of edges in spanning tree should be equal to v minus 1. That is the total number of vertices in the original graph, which is 1, 2, 3, 4. The number of edges in the subgraph should be v minus 1. That is 4 minus 1. That is equal to 3. And we see it's 1, 2, and 3. So any subgraph of the original graph which possesses these 3 capabilities or capacities or features, that's there should be no loop, there should be v minus 1 number of edges, and it should contain all the original vertices of graph. That will become spanning tree. Okay. But the case arises here that if we now start from 1, that is this, we go to 4, from 4 we go to 3, from 3 we go to 2, with corresponding costs attached with every edge. This is also a spanning tree of the original graph, ST2, because the total number of vertices are same, there is no closed path, the total number of edges is equal to the total number of vertices minus 1. So if we see here, the cost was 5, total cost I'm talking about. The total cost was 5 plus 3 plus 6. That is equal to 14. And the total cost of this thing is 4 plus 3. Similarly, there could be another spanning tree. We will start from 4, we go to 3, we go to 2, then we go to 1, or we can erase this one. We can erase this one. Okay, this will become the new spanning tree. Yes, all these subgraphs are the spanning trees of the original graph. And when we calculate the individual cost of every subgraph, we get different costs in every spanning tree. And the minimum cost subgraph, that's minimum cost spanning graph, is known as the minimum spanning tree of this graph. So out of all those spanning graphs or spanning trees, the minimum cost, the graph which has the minimum cost, that is known as the minimum spanning tree. Yes. So when we calculate all the spanning graphs of a particular graph, the one which is having the minimum cost, and that graph will be only equal to 1. That will be only 1, the minimum one. Like there are multiple number of spanning graphs or spanning trees, but the minimum one will be always only 1. And how to find? Because like we did in the previous lecture, how to find that one spanning tree of minimum cost. It's not like we will always find out these multiple number of spanning trees, calculate their cost, and then the minimum cost among them will be taken as the minimum spanning tree. So there should be an algorithm which will directly tell us how to calculate that. And those are the algorithms for finding the minimum spanning tree. And there are two algorithms for finding the MST. The first one is of the premise algorithm. Premise algorithm. Okay. If we apply the premise algorithm on this, if we the previous graph which will hang 1, 2, 3, and 4. The corresponding cost attached was 3, 6, 4, 2, and this was 5. So the premise algorithm says that when we have to find a minimum spanning tree of any graph, that will be both spanning tree as well as the minimum, having the minimum cost among all. So among all the edges inside this original graph, take that edge which is having the minimum cost among all. So among all those edges, the one having the minimum cost, that is edge 2 to edge to vertex 4, which is having the minimum cost equal to 2. Okay. Now the next edge in the graph which we have to take, that should be having the minimum cost among all the remaining edges. Suppose this edge we have taken. Now the remaining edges are this, 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 this. We have to take the one whose cost is minimum. And now the remaining edges are, here it is 3. So the lowest cost is 3. But we have to also keep in mind that the one edge which we have taken, this new edge which we are now taking, that should be connected to this one. That should be connected. One of the sides of this edge should be already connected to this edge which we have taken. So we will take from 2 to 3, and the cost of this is equal to 3. Okay. Now this is also gone. This is gone. We are remaining with 3 edges, 6, 5, and 4. So which one out of them is the minimum? It is 4. So we will take this edge 4, but we have to see, is it connected to the previously generated tree? The graph which we have generated, is it connected to it? Yes, it is connected to here. From 4, we will go to 1 with cost of 4. Okay. So this became a tree, means there is no closed path, there is no cycle inside the subgraph. The total number of vertices are 4, these are 4. The total number of edges inside this graph is vertices minus 1. 4 minus 1, that's 1, 2, 3. And the total cost will be 4 plus 2 plus 3, that's equal to 9. Okay. And this is the principle of the premise algorithm. This is how the premise algorithm works. Okay. So if we see the working of the premise algorithm now on a second graph, which is a little bit complex than this one, we will take the example here. So we are having 1, 2, 3, 4, 5, and 6 vertices in total. These are the respective costs associated with every edge. And there is one more vertices in between, 14, 24, and it is connected to 4 here with a cost of 18. So what we are interested in finding the MST by using the premise algorithm. So the first step is that we will take that edge which is minimum among all the edges inside the graph. And that edge in the present graph is in between the vertices 1 and 6. And the cost of that edge is 10. This will become the minimum first edge from the graph. Now, the second could be that we have to take the second minimum edge from this graph. And the second is which one? So this one we have taken. So what we have to see is to find the next minimum edge. That could be 12, but since the premise says that it should be connected to the already existing edge which we have taken. So we are having two nodes, 1 and 6. We have to see which edge is connected to node 1, which edge is connected to node 6, and out of those connected edges, we have to take the one which is minimum. Okay, so we can't take this 12 because if we take this 12, it will become like 3 and 4. This will be here 12, and there is no connection in between the two edges. The prim says either it should be connected in this direction or it should be connected in this vertices. So we can't take this one. We have to take the one which is connected to the previously taken edge. So we have to see which edge is in the line now. There are two edges connected to these vertices. One is from this side, which is 28. One is from this side, which is 25. So we have to take the minimum. So we will take this one, 25. And this will be connected to the vertices 5. So this one is now also explored or taken. Now we reach to the vertices 5 and vertices 1 are now there, which could be connected furthermore because this is now gone, 6. So vertices 1 is hang 28 on this side, this, and vertices 5 is connected to 24 on this side and 22 on that side. So out of 3 edges, we had to take the one which is minimum in cost. So we will take the edge 5 to 4 and the cost is 22. Now we have reached to vertices 4. Now it is connected to 12 on this side, 18 on this side. Okay, only 2 edges are connected to this 4. So we have to see which one we can take. We have to take the one of minimum cost. 4 to 3, it's 12. So we have reached vertices 3. We will reach vertices 3. Now we will see to which vertices it is connected. It is connected to vertices 2 with a cost of 16. 2 with a cost of 16. Okay. So we are now left behind with only one vertices, that is 7. 7. We can reach 7 either from here, either from here, either from here. If we go from 5 to 7, 5 to 7, it will make a closed path. And MST does not allow a closed path because MST itself stands for minimum spanning tree. Means the subgraph should be a tree. It should not be a closed path. So this is not an option. We can go from 4 to 7. That is from 4 to 7. Again, it will make a closed path of 4 vertices. So this is also not an option. So the only option is then 2 to 7. 2 to 7 with a cost of 14, and that is also the minimum cost. So all the conditions will be satisfied, and the total cost of this minimum spanning tree will be the addition of all those, and that is equal to 99. All right, आपको समझ आ गया आज? So in the bold terms, we can say that a graph is a set of two components, vertices and edges. The vertices in the initial case which we took the example of, for example, it could be 6 vertices are there in a graph, 1, 2, 3, 4, 5, 6. The edge is a connected set of the edges in between vertices. 1 to 2 के दरमियान एक edge है, 2 to 3 के दरमियान, 3 to 4 के दरमियान, same way. Okay, and this is the definition of a graph. And a spanning tree, spanning tree, spanning tree is a subset of this graph itself, because we are taking the spanning tree as a subgraph of this graph. And this spanning tree is also composed of a set of vertices and a set of edges. The set of edges is equal to the, if I denote it v dash minus 1. Okay, because the total number of edges inside this spanning tree should be 1 less than the total number of vertices. And the vertices here is again the vertices of this subgraph. Okay, so only thing which changes in the spanning tree is the number of the edges. 3 things. First one is that no closed path should be there. No closed path or circle. All vertices in original graph should be in subgraph also. Spanning tree. All vertices in original graph, that's V, should be in sub spanning tree. And here the edges should be equal to V minus 1. If any of the graphs satisfy this condition, it becomes a spanning tree. And minimum is when we take the minimum cost. Any doubt in this? So then I will stop here, huh? We'll then start from the next algorithm in this graph analysis from tomorrow. Online people, if you are having any doubt, you can contact.